Right, so this is the screencast to show you how to complete this Usain Bolt case study. So the first question we got is here. What is Bolt's average speed? So if you go to the triangle that you need, if we covered up speed, ignore speed, we know the speed equals distance over time. So let's go back to the Usain Bolt case study. So we know he's run 200 meters in 19.9 seconds. So distance is 200 meters, and it would be divided by 19.19. So we know his average speed, I'm going to round it to 2 dp, was 10.42 meters per second to the minus 1. So speed equals distance divided by time, which was 200 meters divided by 19.19. That equaled 10.42 meters per second to the minus 1. So we've done question 1 already. Next up, I believe, was displacement. Oh, sorry, no, average velocity. So what was Bolt's average velocity? So we need the different triangle this time. So we need this triangle here. Average velocity, so we can see that's displacement over time. So a very similar question to what we just had. Now if we go back to the original slide, you can see here Usain Bolt's telling you what the displacement in the 200 meter race is. It's 128.3 meters at an angle of 36 degrees. So what you'll need to do to work out velocity is 128.3 and then divide that by the time. So if I bring the calculator back up, let's clear this. Let's clear that. So 128.3, and we divide that by 19.19 equals. So we know our average velocity, excuse me, was 6.69. I'm rounding it to 2 dp again, don't forget. So 6.69. So if I go back to our Word document, so velocity equals, so displacement over time. So we know that was 128.3 divided by 19.19, and let's just double check on the calculator, that equaled 6.69, and that would be meters minus 1. However, this is a scalar quantity as its velocity, so we know it has a direction. So if we go back to the slide, you can see the direction is 36 degrees, so you need to mention that in your answer at 36 and then insert symbol degrees. There we go. That's question 2 then. Right, let's start working on the harder of the questions now. So we want to start looking at interval times now. So what was Bolt's speed at each interval? So what was his speed during the first interval, 0 to 50? So again, go back to your triangle. So we need this triangle again now. So we're looking at speed. Again, it's just distance over time. And let's go back to the Bolt one. So for the first one, 0 to 50, took in 5.67 seconds. Now we know the distance is 50 meters because we're going in intervals of 50. So it would be 50 divided by 5.6. So if I clear that, 50 divided by 5.6. So Bolt's speed for the first interval, if I round it up again to do 2 dp, was 8.93 meters seconds to the minus 1. So we'll just write that here. Not the 50 meters, and it was 8.93 meters a second to the minus 1. Okay, now we're looking at 50 to 100. So go back to the PowerPoint. So we can see he's got a little bit quicker as it's taking less time, 4.3 seconds. Again, 50 to 100, that's 50 meters again. So 50 divided by 4.32, that equals 11.57. Always remember, you've got to put your units in, otherwise it means nothing. Go back again. Right, clear that. So, like I said, it's always 50, and you're going to divide that by 4.52. That is the time by there. And that equals 11.06. Right, now we're going to work out the final interval of Usain Bolt's world record run. So, again, 50 meters. Divide that by 4.75, 10.53 when I round it up to 2 dp. Okay, the next one is all about Bolt's acceleration at each interval. So we don't have a triangle for this, but I pre-wrote it at the top here. So acceleration, it equals final speed minus the starting speed. You have to work that out first and divide it by time. You can also get rid of speed for velocity, but for the purpose of this question, we were just looking at speed. So now we have to try and work out excuse me, we have to try and work out the acceleration at each interval. So we got our speeds here. We've just worked out our speeds. So these are the speeds at each interval. So what I'll do, I'll work them out next to them for you. Makes it easier to see. So what was Bolt's acceleration at each interval? So we've got the 4 intervals there. First interval we're looking at, his final speed was, if we go back to the Word document, 8.93. His starting speed, he's starting on the starting block, so starting speed was 0. So to work out his acceleration here, I need to do 8.93 minus 0. Obviously it's going to equal 8.93 again. Okay, and then all you're going to do is divide it by the time it took him to do it. So go back to the slide. And time was 5.6 seconds. So divided by 5.6 seconds, and that equals 1.59. meters a second. This time is minus 2. So we're looking at acceleration. Right. What is it going to be this time? So here is our final speed, and here's our starting speed. So first of all, on the calculator, you're going to have to do 11.57. You're going to have to minus 8.93, because his final speed going out of this interval is here, and his speed going into the interval is by here. So equal that. That's 2.64. Let's find out our time. It was 4.32, so we'll divide it by 4.32. Divide by 4.32. That equals 0.611. So if we go back to the Word document, 0.61, so I'm rounding up. Meters, seconds to minus 2. So that's his acceleration there. Basically means every second he's getting this much faster, this much quicker. So now we've got 11.06 and 11.57. So you can probably work out now you're going to get a minus answer, because your final speed is slower than the starting speed. So if we clear this now, our final speed was 11.06, and you minus that by the starting speed, which is 11.57. So that's minus 0.51. And again, we go back to the time, which was 4.52. So if I divide that by 4.52, that equals minus 0.11. So if we input that, minus 0.11 meters a second, so minus 2. Now, because you've got a minus there, that means he's decelerating, he's getting slower. So every meter that he runs, every second, that he runs, he's getting this much slower per meter. He's covering less ground. Right. The final one, and then the Usain Bolt case study is complete. So again, you can see that his final speed by here is slower than his starting speed. So again, we know we're going to get deceleration. We know we're going to get a minus answer. So let's go back to the calculator. 10.53 minus 11.06 minus 0.53. Let's get the time again, which is 4.75 seconds this time. So divide by awful memory, 4.75 seconds. That equals minus 0.11 again, because we're just rounding up to the 2dp. So if I go back there, minus 0.11 meters seconds to minus 2. And this is the Usain Bolt case study complete. So here is his average speed, which you worked out for question 1. Here is his excuse me, average velocity. Don't forget that we've got 36 degrees there because it's a scalar quantity, which means it must have a direction. Here are his speeds at each interval and his acceleration corresponding to each interval. So you can see how we started off really quick. Obviously, he starts on the starting block, so you're obviously going to start at 0. So he's going to have rapid acceleration at first, and then there's steady decline in his acceleration, because obviously, if we link this to physiology, this is where his energy systems are transferring from one to the other, and fatigue is kicking in. Anyway, that is how you complete the Usain Bolt case study. Any questions, just drop me an email.